this video, I'm going to show you the basics of how to solve an equation with a radical in it. In the next video, I'm going to show you how to solve slightly more complicated versions of this exact same concept. So the first thing we're going to notice is the new part that we have right here is our radical sign in our equation. Now, in order to solve equations, we all know that we have to do opposite operations or undo certain operations. For example, the opposite of multiply is divide. The opposite of add is subtract. So we're going to do those things to isolate the variable in order to find out what that variable is. But now that we have this radical in here, the first thing we want to do is isolate the radical. This is going to allow us to undo it by squaring it. So for example, the first thing I'm going to do is I'm going to subtract this x over to the other side. That gives us a 0. Have the square root of x minus 1 equals 3 minus x. Now, here's why we do that. Because now I can just square both sides. Okay, now you have to be careful. This entire left side is underneath the radical, which means I'm squaring the entire left side, which means the opposite operation of a square root is a squared. So essentially what happens is those two things undo each other, kind of like a cancel out, and I'm left with an x minus 1. Okay, let's move on to the other side. This is the number one mistake people make. They think that they can just distribute this square out to the 3 and the negative x, but that's incorrect. Let me show you why that's not right. Okay, we only have a portion of it, not the entire thing. Remember, this squared is like saying I've got 3 minus x times 3 minus x, which would end up getting us a double distribute right there, okay? And then I have to distribute that negative x. So what we end up getting is 9. I got minus 3x and a minus 3x and then a plus x squared. All right, we've got 4 terms that we can now then put these two together. I'm going to rearrange a little bit and we go x squared in the front minus 6x plus 9, and all that equals x minus 1. Okay, so be careful there. A lot of people tend to leave out this middle term by just distributing that squared, and that's not what we're doing. We're taking two binomials, multiplying them together, which ends up giving us a double distribute. Look right there. Okay, now let's continue on. This is just like a quadratic now, right? We've introduced a squared into this, so I'm going to solve a quadratic equation, and to do that, I'm going to get 0 on one side, so I'm going to subtract x and add 1. So subtract x, add 1 to both sides. That gives me a 0. That gives me x squared minus 7x plus 10, and that equals 0. And from here, we can now factor that into two binomials of x minus 5, x minus 2, and set each binomial or each factor equal to 0 and solve. So I'm going to go plus 5 plus 5. So I've got my first possibility of being x equals to 5. And then I'm going to go plus 2, and I have my second possibility at x equals to 2. So now what we have here is we have x equals 5 and 2. Now, one more thing before we finish this. Very important that we check for what's called an extraneous solution, meaning a solution that we get algebraically, but when I plug it back into the original, it doesn't make sense and doesn't work, therefore making it not a solution or extraneous. So I'm going to start by plugging the 5 in to both the x's. So I have the square root of 5 minus 1 plus 5 equals 3. And then I get the square root of 4 plus 5 equals 3. Square root of 4 is 2 plus 5 equals 3. 7 equals 3. And I know 7 does not equal 3, which makes 5 extraneous, so I'm not going to use it. All right. Now let's go check the 2. Plug that in. I have square root of 2 minus 1 plus 2 equals 3. 2 minus 1 is square root of 1 plus 2 equals 3. Square root of 1 is 1 plus 2 equals 3. So now I have 3 equals 3. So that checks out. And the only solution that is in fact correct is x equals 2. And that's the only one that we're going to use. So we can go back and clean our answer up a little bit, and we can say that x only equals 2. And that, remember, that 5 is not correct because it is extraneous, meaning it doesn't work out when I plug it back into the original. All right, here is a problem for you to try. Pause that video, give it a try, we'll come back and check it. Alright, now that you've had a chance to try this on your own, let's go ahead and start by solving this. Now, in order to take care of this radical, the first thing I want to do is isolate it. So I'm going to move that 6 over, get the square root of x plus 5 over on the right side, right, x minus 1 on the left side. Now, since the entire right side is under a radical, I can square it so that those two operations will undo each other. And I have to square this one, get x plus 5. Be careful here not to just distribute that squared, because that's not how we do it. We have to take that binomial and square it like this. So now I get x times x times minus 1 times x, and minus 1 times minus 1. So I end up getting a trinomial here, x squared minus 2x plus 1. I'm on minus 5 and minus x, so I can get 0 on that right side. So I've got minus 5 and minus x, so that gives me x squared minus 3x minus 4. Now I factor it to two binomials, get x minus 4x plus 1 equals 0. Got x minus 4 equals 0, x plus 1 equals 0, plus 4 plus 4. So one possible solution is x is equal to 4. And the other possible solution is x equal to negative 1. So now I'm going to go back to my original. X plus 5 equals square root of x plus 5 plus 6. I'm going to plug in my 4. I got 4 plus 5. Got the square root of 4 plus 5 over here, plus 6. So we have the square root of 4 plus 5 square root of 9, which is 3 plus 6. And then 4 plus 5 on the right side is 9. 3 plus 6 is 9. So the 4 checks out. I can use that one as one of my solutions. Let's go check this negative 1. So I got minus 1 plus 5. So I'm going to go and simplify that left side first and get 4. Got negative 1 plus 5 plus 6. So I got the square root of 4 plus 6. And now I hope you can start to see I've got 2 plus 6 equals 8. And I know 4 does not equal 8. So I'm not going to use that negative 1 as part of my solution because it is extraneous. And the only solution I have is x plus 4. All right. Hope this video helps. I will see you in the next one.